Hello, geometry friends. Today we are going to talk about rotations on a coordinate plane. And this is the third and final type of rigid motion that we are going to discuss. And so let's kind of do a quick review here. What we're going to look at first is what happened to each of these that are already pictured. So if I look at this first one, that top triangle flipped over the x-axis to become the bottom triangle. So what's the type of rigid motion? A flip is a reflection. All right. And is size preserved? Well, yeah, all the lines stayed the same length. So then, yes, size is absolutely preserved. Is orientation preserved? Orientation is the order that the vertices go in. And the one on top goes ABC if you're naming counterclockwise. And the bottom is ABC if you name it clockwise. So no, orientation is not preserved. And fun fact, reflections are the only ones that do not preserve orientation. So what type of isometry is this? Isometry is just a fancy word for a rigid motion, and this is what's called an opposite isometry. Because when you flip something, you see the back of it, you reverse orientation. Still stays the same size, but technically you flipped it over. All right, and then if we look at the next one, how did I go from ABC on top to ABC on the bottom? Well, this one looks like it turned a little bit. Like C kind of went like this. A kind of, yeah, they all turned. Okay, so this is a rotation. It did not change size, so size is preserved. Orientation is preserved on anything except a reflection, which makes this what's called a direct isometry. And then last but not least on this one, we just took that whole triangle and slid it straight down. A slide is a translation. It does preserve size, it does preserve orientation, and it is also a direct isometry. All right, so quick review. Now the one we haven't learned how to do yet though is this rotation, so that's what we're going to get to today. So a rotation is a rigid motion that turns a figure about a fixed point called the center of rotation. Fine. The angle of rotation is the number of degrees it rotates. That makes sense. Please remember that a positive angle is counterclockwise. Negative is clockwise. All right. And this is going to be a direct isometry because it preserves orientation. An opposite isometry is for reflections. So let's turn some stuff. So this one says, take the point 4,2 and rotate it as stated. So we want to rotate 4,2, which is right here. We want to turn it 90 degrees. Now, since that says it's a positive 90, we're going to turn it counterclockwise. Now, I would like you to direct your attention over to here where I have cropped that same image. If I want to turn this clockwise, counterclockwise 90 degrees, I'm going to rotate it left 90. Okay, now what I want you to do is literally turn your paper a quarter turn counterclockwise, and that's what I'm going to do. So I'm going to rotate it left 90. When I do that, that point now went from it was here and it turned up to there. Well, where is that now? If I think of this as a regular XY axis, that's left 2, up 4. So this new point is right here, and I do want you to write this down. So that is left 2, up 4. So my new point is -2, 4. Okay, well, what if instead of 90, we went 180? Instead of 1 quarter turn, that would be 2 quarter turns. So I'm going to take this, and I'm going to rotate it left 90 again. Really, what I did is turn it upside down. That point that was originally over here in the right quadrant is in the bottom left quadrant, left 4, down 2. 1, 2, 3, 4, down 2. So we went from 4, 2 to -4, -2. And if I want to go 270, that's 1 more turn. And now I'm right 2, down 4. And then what about negative 90? Well, negative 90, let me get it all the way back to where it started. Negative 90 would be 90 degrees clockwise. So if I orient this back the way it's supposed to be, and then I turn it 90 degrees clockwise, it ends up in the exact same place that positive 270 did. Okay, so a rotation of 90 degrees clockwise brings me back to 2, negative 4. So you can complete rotations by turning your paper, seeing where the point ends up, and then turning it back and plotting it where it's supposed to go. But I think we can all agree sometimes that gets a little out of hand because you're constantly turning and turning it back and, did I turn it the right way? So this is one of those times where I would suggest that maybe you try to remember these rules. So there are rules down here, okay? When we rotated 90, we started with the point 42. It becomes negative 2, 4. So we flip-flop the order and negated just the first one. So xy becomes yx, and then we negate the first one. So swap order, and then change the first sign. That's what we did. When we look at 180, we started with 4-2, we ended with 4-2, but they're both negative. So when we turn 180, xy just becomes negative x and negative y. We change both signs. And then for 270, we started at 4-2, we ended at 2, negative 4. So we flopped the order and negated the second one this time. And then we said 270 and negative 90 are actually the same thing. Okay. So what I'm actually going to do here is I'm going to crop this so I can use it on the next page. Okay. So here's the rules that we had. I have these available, but they're going to get in the way. Let me shrink them. Okay. So on the next page, it says we're going to start with triangle cat, and we're going to turn it 180 degrees and see where it ends up. I mean, okay, fine. I can do that. Is there no exercise 1? Or what just that one? Exercise 1. Okay. Sorry. I just wanted to make sure I wasn't skipping a page and being a silly goose about it. So first we're going to try drawing cat. So negative 1, 2. There's C. Negative 1, 5. There's A. And negative 3, 3. There's T. So there's triangle cat, C-A-T. Graph it. Done. Graph and state the coordinates after a rotation of 180. So what I'm going to do is I'm going to state the coordinates first and then graph it and say, all right, if I'm supposed to rotate 180, I'm going to look at the rule, and that says just keep them in the same order but change both of the signs. So C was negative 1, 2, which means C prime is going to be 1, negative 2. Just change both the signs. A prime, positive 1, negative 5. T prime, positive 3, negative 3. So now I'm going to graph that. So 1, negative 2, there's C prime. 1, negative 5, there's A prime. And 3, negative 3 is right there. So we turned it 180 degrees, just using the rule. What type of isometry is the image? Well, we said on the front, rotations are direct isometries, as it keeps the same size and it didn't flip. All right. Rotating around a point other than the origin. So if we want to do this, things get a little hairy here because I don't have any rules to follow up on. Okay. So what we're going to do is we're going to pretend that we are spinning around the origin, but that somebody just moved the origin on us. So So I want you to just say, okay, if I'm supposed to spin around this other point that they gave us, and I'm supposed to spin 90 degrees, the first thing I'm going to do is put a fake origin in there, and then I'm just going to turn that. So what we're going to do is we're going to fake these values. I'm going to move my face here so I don't overdo it. Based on this new positioning system, A is now 3, 1. C is 1, 2, 3, 1, 2, 3, 4. And B is 1, 1, 2, 3, 4. So based on that fake new positioning system, if I rotate 90 degrees counterclockwise, if I scroll back up, the rule was flip them and negate the first one. Okay, so then the new A would be flipped instead of 3, 1, 1, 3, and then negate the first one. The new B would be flip them, so 1, 4 becomes 4, 1, negate the first one. The new C was 3, 4, flip, and negate the first one. So now I'm going to plot those. Negative 1, 3, negative 4, 1, negative 4, 3. But remember, this was all with a fake origin. Okay, so I was able to turn it based on, again, this fake origin right here. But I can't give you my answer in my imaginary world with a fake origin. I need to give you a final answer in the real world. So the real final answer, we did everything right. We turned it all right. But these are fake coordinates. To get the real coordinates, I just want to look back and count from the actual origin, which is right here. So this A prime from the regular origin is left 2, 1, 2, 3, 4, 5 up. So the real A prime is left 2, 5 up. The real B prime is left 1, 2, 3, 4, 5 up 3. And the real C is left 5 up 3, 4, 5. Okay, that part's weird. That part's weird. We're not going to have to do that often, but you can. If you're ever asked to spin around something that's not the origin, you just fake it, rewrite everything as though it were the origin, and then recount based on the original origin when you're all done. And that's it. That's all I have for rotations. So I hope everybody is having a glorious day. I'd like to be able to give you a good joke today, but I got to be honest, I don't really have a good joke. I just got really corny ones. Like, what do you get when you cross an elephant and a kangaroo? I don't know what it's called, but it's making holes all over Australia. Nah. All right. Have a good one, everybody.